Alright, in this video here we're going to be talking about compound fractions, which what a compound fraction is a fraction in which either the numerator, the denominator, or both contain a fraction. Right? So it's like we have fractions within fractions. That's what we call a compound fraction. Right? So what I'm going to do here is just do a couple examples where we simplify compound fractions. Right? When we talk about simplifying a compound fraction, basically we don't want to leave fractions within other fractions, right? We want to be able to take something that looks like this, where we have the fractions in the numerator and denominator, and write that as just a single fraction with one numerator and one denominator, and no other fractions within the numerator and denominator, right? That's what we mean by simplifying a compound fraction. All right, so we have x over y plus 1 in our numerator, and then we have 1 minus y over x in our denominator of our compound fraction. All right, so one of them, there are a couple ways you can go about simplifying a compound fraction. One method, which is the way I'm not going to do it here, because for me it seems like that's a little bit too much work to do. But one method you could do is find a common denominator in your numerator, find a common denominator in your denominator, and combine everything together in the numerator and denominator, and then thinking about it as like dividing two fractions and you know, multiply by the reciprocal and all that. But to me that's kind of a lot of work. There's a quicker way to do it. Right, and the quicker way to do it is look at the what I call the smaller fractions that you have. Right, the smaller fractions I mean here are the x over y and the y over x. Those are the fractions that are within the bigger overall fraction. Right, and what I want to do is find the common denominator of those smaller fractions. Well, this smaller fraction has a denominator of y. This smaller fraction has a denominator of x. So my common denominator of those two smaller fractions is going to be x times y. All right, it just, you know, multiply this denominator times that denominator. That gives me the common denominator of those two smaller fractions. All right, so what I do then with that common denominator is I'm going to multiply that common denominator times the numerator and denominator of my bigger fraction. Right? Remember, I'm allowed to multiply the same thing on the top and the bottom of a fraction, because when I multiply x over y, or when I multiply by xy over xy, that's just multiplying by 1. It doesn't change the value of my overall expression. All right? So when I do that, let's see what happens. Let me erase this common denominator thing here so that I have some space to write this. So think about this as these things in parentheses, and I have to distribute that xy times all the stuff that's in that numerator. Well, when I multiply the xy times the x over y, well, let me just write it out, and then we'll do the simplifying part in a second. So it's going to be x over y times xy plus, and then when I do the xy times 1, that's just going to be xy. Right, because I'm just multiplying it by 1, so that's pretty simple. And then I'm going to do the same thing over here, or in my denominator. I'm going to multiply my xy and distribute that into that parentheses in my denominator. So xy times 1 is just xy, and then minus, and then I'm going to have y over x times xy. All right, so again, what I do is I get my common denominator from all of my little fractions. I multiply that to the numerator and denominator of this bigger fraction. Now, the reason I do that is because when I multiply that xy times the x over y here, what ends up happening is that the y in my denominator cancels out that y that I'm multiplying into it from that common denominator that I found. All right, so those y's cancel out, and what I'm left with is x times x, which is just an x squared. All right, so it's x squared plus xy over, and notice that extra fraction that I had in my numerator has now disappeared. I no longer have another fraction in my numerator, right? And the same thing is going to happen in my denominator. I'm going to have the xy here minus, and then when I do y over x times xy, the x is going to cancel out the x in the denominator, and I'm going to have a y times y, which equals y squared. Right? And that fraction in my denominator has now also disappeared, and now I have just a normal fraction where I don't have a compound fraction anymore. Right? So that's why we have to find the common denominator for the top and the bottom, right? Because when I multiply the xy, it has to have a y here, so that when I multiply it by this fraction, it cancels out this y. It has to have an x in it, so that when I multiply it by this fraction, it's going to cancel out that x. Right? So that's why it's important at the beginning to get the common denominator from all those smaller fractions, and then when you multiply it through, it should cancel out every single fraction that you have, if you chose your common denominator correctly. All right, so now we get x squared plus xy over xy minus y squared. And now we just have to see, well, can I simplify that at all, or is that all there is to it? Well, I can factor this a little bit, right? The stuff that I have in my numerator, they have a common factor of x, right? So I can pull out the factor of x, which would leave me with an x plus y over, and my denominator, those terms in the denominator have a common factor of y. So if I pull out the y, that leaves me with an x minus y. And it turns out that nothing actually cancels. It's close, right? I have an x plus y factor up here, and I have an x minus y factor down there. But those are not exactly the same, so I cannot cancel those out. And so that's my answer. X times x plus y over y times x minus y. That's what I get when I simplify that compound fraction that I had before. All right, so finding the common denominator of the smaller fractions, multiplying that through the bigger numerator and denominator should cancel out all your smaller fractions, and that's one way that you can simplify a compound fraction. All right, I'm going to pause the recording here and put up another example where we work with some more compound fractions. All right, I put up another video here of a compound fraction. So this one is 1 over a plus h minus 1 over a, all of that over h. And this is the type of expression that you'll see in calculus if you go on to take calculus. When you start learning the definition of what a derivative is, which is like one of the major topics of calculus, this is something called the difference quotient, which is one of the key topics in the beginning of a calculus course, right? So it is definitely something, if you continue going through mathematics, that you will see again, having to simplify something like this. All right, so 1 over a plus h minus 1 over a, all of that over h. All right, so if we take the same method as we did for the last one that we just did, I have two fractions in my numerator, none in my denominator, but I can still use the same basic method here. I look for the common denominator of my smaller fractions, which this fraction here has a denominator of a plus h, and then this fraction over here has a denominator of just a. Right? So my common denominator is going to be a times a plus h. All right, now a lot of people might think, well, there's an a here, but this also has an a in that a plus h, so shouldn't the common denominator just be a plus h? It's not, because remember, the common denominator involves factors, things that are multiplied together. The a and the plus h are not being multiplied together, they're being added together. So this a plus h is one factor unto itself, and this a over here is a completely different factor. Right? Think about it in terms of like numbers. Like if a was 3 and h was 2, well, this would be 3 and this would be 5, and they don't have anything in common, right? So the a and the a plus h are two different factors. That's going to be my common denominator, right? It's going to be a times a plus h. So what I do then is I take my larger fraction and I multiply both the numerator and denominator times a plus h. All right, so I multiply that on the top and bottom of my larger fraction. And remember, I'm allowed to do that because I'm really just multiplying by 1, so I'm not changing the value of all this stuff. I'm just changing the appearance of it. And again, multiplying by a 1 like this is a real common method that you use in mathematics, especially as you go through higher levels of math and precalculus and calculus and stuff like that. Multiplying by a 1, but choosing that 1 in such a way that it's going to allow you to simplify things or combine stuff together, a very common method that you'll see. All right, so I multiply by a times a plus h. So just like in that last example we did, I'm going to have to distribute that to all the stuff that's in my numerator. All right, so it's going to be 1 over a plus h times a plus h, and then minus this fraction 1 over a times a plus h. Right, so it's this one here being distributed to both of these fractions. That's what I end up with. And then in my denominator, it's basically just h times a plus h. Right, so this h multiplies this a. There's only the one term in my denominator here, just the h, so I don't have to distribute it or anything. I just multiply this times this, so I basically just run them together. H times a plus h. All right, and what happens in my numerator now, just like in that last example, my fraction should cancel out if I did this correctly. All right, so here the denominator is a plus h. That cancels out with that a plus h factor that I'm multiplying into it. So I just get 1 times a, which equals a. Pretty nice. All right. On this one, my denominator is a. That cancels out with that factor of a that I'm multiplying in. So I have a minus, and then I have this 1 times a plus h. So that's going to be minus a plus h. All right. And then in my denominator, I still have ha times a plus h. All right. So that is, we've now eliminated those fractions within the fraction. So I no longer have a compound fraction here. Now I just need to see if I can simplify this anymore. And in this case, I actually can. Right? Because I can distribute this negative here. Remember, when I have a negative outside of a parentheses, I need to distribute it and multiply it times everything that's inside the parentheses. So I'm going to end up with a minus h, right? So the minus goes to the a and to the h, over ha times a plus h. And what happens in the numerator here with that a minus a? That cancels out, right? A minus a equals 0. Right? So those a's cancel out. So I have a negative h over ha times a plus h. And now what happens is that h that I have in my numerator, since it's the only term left in the numerator, that cancels out that factor of h that's in the denominator. And so what I'm left with now, well, you might say, well, everything in that numerator got canceled out, so it's just a 0. Remember, it's not a 0. There's still something there. For one thing, we still have that negative that's in front of the h. And when that h cancels out, it leaves me with a 1. Right, so it's going to be negative 1 over a times a plus h. And that will not be able to be simplified anymore because all I have is a number in the numerator. And so I'm finished. Right, just like when you have like a 2 over a 4, like when you simplify that fraction, well, remember the 4 is 2 times 2. So when those 2's cancel out, it doesn't leave you with a 0. It leaves you with a 1/2, right? There's still that 1 up on top when that 2 gets canceled out. Same idea here. When that h cancels out with this h, that h becomes a 1. That negative in front of it is still there, so it's now a negative 1 over a times a plus h. All right, so that's what this compound fraction that we started with up here simplifies to, is just negative 1 over a times a plus h. All right, so that's a couple examples of dealing with compound fractions. Like I said, this type of expression that you see here is something that you will see again when you get to calculus, presuming you go that far in mathematics to get to calculus. But you need to be able to work with those types of compound fractions. It's not the kind of thing that comes up all the time. It's not like every day in calculus you have to do stuff like this, but it will pop up here and there every once in a while. So you do need to be able to be comfortable enough with these types of fractions and just understand that if I need to cancel out the denominators of these fractions, I just need to multiply everything by the common denominator. That's going to cancel out all those denominators and allow me to simplify my fraction. That's the key thing that we do here.